Hello everyone, Adam Skotnický, TCP Cloud CEO, and this will be again replay of OpenStack Summit part, but I give you a little bit more glimpse into technology, because of course this is technology conference, right? So first, what we are doing, we are cloud builders. We're building enterprise private cloud for telcos all over the planet, basically in Europe, States, some Brazil, some India. We're sourcing every night more than 120 open source software projects, and then we're building some reference architecture models, basically from bare metal in the data center up to some application support logging and user dashboards API layer. This is cloud, right? Everybody thinks that clouds are somewhere else, above us, but in the end it's traditional data center workload, nothing else. It's just about how this is managed. And during the December last year, we decided, based on this project, to a little bit expand the cloud itself from data center to outer parts like city parts, industrial zones, and, for example, smart conference, right? So this is one of the projects and team we work with. And this is just city. This is not like one project, it's more like framework of projects. We're working with biggest companies and universities to bring something. Especially for this part, we will talk about partnerships with, of course, Protronics, Microrisk, TCP Cloud, and IQRF Alliance. We are a member of IQRF Alliance right now also. And let's go to use case. So traditional use case, everybody knows it. This is the main idea, right? Let's place hundreds of sensors, thousands, billions, doesn't matter, all over the place, and start measure everything what is possible. That's the idea. But of course, there was talks about how to get the data from one point from the sensor to the gateway and to some mesh network local area. But whatever, if you have conference in the United States and data center in Europe, how you want to manage it. It's basically something what we call cloud. And we are more focused about how to build this. So this is something what we call high-level architecture, and this is something what we execute. This is Bubble first, right? December last year, this is Bubble. Right now we try it in real. And funny is that we did it in 30 days together with IQRF Alliance. We just met one day, and 25 days after, we presented in the keynote, including manufacture of sensors, so everything was done in 30 days. So first part you know real well. So from sensor to IQRF to gateway. For us, gateway could be whatever. It's basically, gateway is just some, for us, Linux machine where we can execute something. This is the base model, right? We have something what we get. We push it through like a DPA packet to gateway, and from gateway we connect it through internet to data center. At best, there is some cloud platform. Usually there are no cloud platforms. There are some Linux machine or Windows machine collecting data and do application. That's the almost worst case scenario for IoT because it's really rigid. You cannot work with this. So we have OpenStack Cloud, right? So what about if you want to access multiple sensoric networks? What about if you want from gateway itself collect another data, not just from IQRF networks? What about different, for example, USB, IP camera, some heavy lifting workloads? There's everything on the gateway. How you want to manage it? You have different lines. You can have different data centers. So for that, we expanded to the Kubernetes. Kubernetes is basically container. I don't know if you are familiar with containers. It's something like virtual machine, but much smaller. And we are able to put something like virtual machine into gateway itself, and we did it together with Docker. And it's still, you are not able to manage these containers. Imagine you have 100 containers in one small Raspberry Pi, and you push all the data you collect through the internet. Of course, first line, VPN. It's really a good idea, but in the end, VPN is really something that will limit what you are doing. And you need a little bit more handle the traffic. For example, if we talk about IP cameras, so the IP camera should go to the different server than data from sensoric, whatever, temperature, CO2 levels, and whatever. And for that, we have another line, and that's SDN. So that's what we push outside from the data center is SDN. SDN is software-defined networks. This is something what changed data centers globally, and it's part of cloud movement or cloud technologies. Is that the network itself, the IP networks, it's absolutely scalable to billions. IP itself, it's not unique anymore. It's just another. It's like MAC address. You can hack it, you can change it, and we don't care because it's something which we can 100 times same IP address. Not imaginable before. And for that, we are able then get the data, push them to the network, and process them during the time. So in the end, we are able to do in scale, real time, do security, do backup, do routing. We can process one part from the gateway in the one data center and second part in another data center. And yeah, of course, visualization APIs. And this is what we did in Austin. Basically, this is real map of the venue. By the way, this area is huge, so much that more than 7,000 people fits in. So just for imagination, how big is it? And we place IQRF sensors inside, and we took just one Raspberry Pi, and we connect everything together. Of course, that's the idea of IQRF. And true is that everything works fine till someone starts tearing down our sensoring and looking inside what's inside the sensor. That was some catches. So we tape it like too much to be too difficult to go inside. So that's just some production experience. Everybody knows that. And we transfer the data online to data center in Czech Republic. So fun is there's half hour away, and this was still just 100 millisecond delay from getting data and transfer them to the dashboard APIs or whatever. So this is pretty much real time. Again, there's no specification what is real time, but if you ask right now what is real time, usually it's like same day. We talk about hundreds of milliseconds. So this is something what Shimon stole from me, but yeah, 20 sensors, 20 IQRF mesh routers, 3 gateways just for backup if somebody stole it or we broke it, and we did it, by the way, and 43 devices. That's total, and we install it during 2 to 3 hours, just running around venue 3 times because somebody broke everything. But that was really easy to install and operate. And that's why I have this speakerphone, because I want to show you how this look like. So we put together some demo website for Austin, and this is just basic information. And also there's some, I have no internet, sorry. Just a second. Já už to připojím. Já jsem vypl telefon. Yeah. So. One more time. So there's our dashboard. So this was real-time data from sensors in the building, and there was some historical data. This is something what I show you later. I have recorded in my backend. But what is important that we put together some metric definitions and APIs, to be metrics 2.0, so you can get real-time APIs. The real-time APIs look like that, for example. So this is the RESTful API available for everyone. And what is important that if you go to our metrics, this is the metrics from the conference, and this is the 3 days. If you go for first day, we can see some metrics, in real time. This is the keynote. Now, so what is important? There are more stuff what is our outcomes? What we did? First, of course, great marketing session, great promotion and everything. But everybody thinks that this is all. This is just like showcase for something what IoT can do for conference. But in the end, we found something. We found that there are all limits for Ashura, OSHA limits for United States indoor conferences or everything events are 2 times higher than is legal. So in fact, they should close the conference and push all the people outside, ventilate and do it. 7,000 people. That's not right. So guys from OpenStack Foundation asked me if it's okay. So we should speak with conference people and with legal stuff in Austin if it's okay to let people inside. But in the end, that agree that's fine. But in the end, this is the keynote. This is where all session starts. This is where launch starts. So you see, everybody's on the launch, and during the day, we see how this works. In CO2, we see that it's something which is not control. Ventilation doesn't work. Everything what you control right now is humidity and temperature. So if we go for humidity and temperature, it's pretty much okay. CO2 nobody measures, nobody controls. CO2 causes most of headaches and everything, because that's the O2, right? Before you need it. And also, what is very important is that this is everything open source, and that's the biggest part. Everything's open source. All infrastructure technologies are now open source. Everything's open for everyone. So, for example, we're now cooperating with University in San Antonio, Texas University, to put these in 200 venues all over the Texas, because they want all these metrics. And by the way, OpenStack Foundation order from us these same technologies for next 2 events in Barcelona and Boston. And the next stuff, it's something what we need to discuss now, because this is fresh information. The next conference in Sydney, they're just building the conference hall, and they won't include IQRF sensors inside the structure from the beginning. So this is just showcase what we can achieve in future. So thank you.